For question 515, we have a bond that pays a 14% coupon semi-annually relative to a $1,000 par value. So this means we're receiving an annual coupon payment of $140, but it's semi-annual, so we're receiving $70 every 6 months. This bond will mature in 30 years, and the bond is callable in 5 years from now at $1,050. That's implying that there's a call premium of 5%. That is the amount over the par value that we receive when the bond is called in. The bond sells today for $1,353.54. What is the best estimate of the nominal interest rate on the bond? So there's a couple things we can get from the information that's provided. We've already figured out what the coupon payment is. We know that it can be called in 5 years from now. And the bond is selling well above par value. What that tells us is our coupon payment must be a lot higher than the rate that's being offered in the marketplace today. So for that reason, we have a high suspicion, or we, with high certainty, believe that our bond will be called in 5 years from now. So we want to price this bond at the point in time when it's going to be called. We don't want to consider all the cash flows out to year 30. If we do, we would greatly overvalue this bond. So the value, that is the present value today of $1,353.54, is based on the fact that this bond will be called in 5 years from now. We then have to figure out what is the discount rate that results in a present value of $1,353.54. So since this bond is semi-annual in nature, or that is the coupon payments, it's 5 years from now, we know that there are 10 payment periods. So at time 0, there's a cash outflow of $1,353.54. Every 6 months, we receive $70 for a total of $140 annually for the next 5 years. At the end of 5 years, we can anticipate that this bond will be called in, and we'll receive a total of $1,050 plus the $70. So a total of $1,120 upon maturity. So as before, there's a couple of different ways we can solve for this. First, using NPV. We use the NPV function. We'll have a guess rate, and then we'll include the cash flows from time 1 into the future, and we'll add back in the cash outflow at time 0. We can still see that there's a positive NPV, and what we're trying to do is get to an NPV of 0. So what we're going to do here is use the goal-seek function to set the NPV to a value of 0 by changing the discount rate. So now remember that when we did this, this is for each cash payment, and Excel is thinking we have 10 years of cash payments, but really we know it's 5 years. So this 3.23% is a semi-annual amount. We then have to multiply that times 2 to get the annual. So the rate in the market is approximately 6.47%. We can also use the IRR. We're not going to offer a guess value. And again, we have to multiply that amount. And lastly, we'll just increase our decimal places. And so there we get the same answer. We can also employ the rate function to solve this question. So we entered so far a number of payments, t times n. We've entered our semi-annual payment of 70, or we could do the 140 divided by 2. Our present value is entered. Now we're going to enter our future value. Now remember, for the future value, that's equal to the return of principal plus the call premium. We know the payments received at the end, and we're not going to guess. We want to make sure to denote that our present value is negative. There we go. And lastly, we need to annualize. And so we see that the annual nominal rate of interest on the bond is 6.47%. So again, there's three different ways you can approach this. You can use an NPV, IRR, or the rate function. Again, remember, if you try to do this manually, you're going to have to use an iterative approach where you guess higher and lower, because you're not going to be able to isolate for R algebraically.